Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we were solving the questions of GATE in 1992. So today we have a new question and in a couple of days, in the coming couple of days, we will complete the section B, then I will upload section A. So today we have a question from mechanical operation. So without wasting time, going to the question. So the question is saying a filter press contains 20 frames each of 0.6 meter into 0.6 meter inside dimension. The frames are 0.025 meter thick. The press is equipped with 1 and 3 buttons made for washing. The volume of wash water used is 10% of the filtrate per second. Volume of the filtrate, the 10% of that filtrate is the volume of wash water is used. The time required for filtering at a constant pressure is 2 hours, by which time the frames are full. For at the constant rate, uh, the process is taking 2 hours, in which the frames are full of the cake. Washing is done at the same pressure as filtering, and the viscosity of wash water is nearly the same as that of the filtrate. So viscosity is constant. Okay. What is the time for washing? There is 0.05 meter cube of final cake per meter cube of filtrate. Neglect the resistance of the filter meter. Okay. So we have to calculate time for washing. For plate and frame filter press, and for plate and frame filter is a continuous filter press, but even for the batch filter, the time for washing is given by volume of the wash water used divided by the rate of washing. This is general formula for all kind of filters. But for batch filter, the rate of washing changes, and for plate and frame filter, the rate of washing changes. So we will see later. So volume of wash water used, 10% of the filter rate per second. So we have put it the value of volume of the wash water used. So 10% filter rate per second. Just directly the value. So we have to find the filter rate per second. What is the volume of filter rate? So here we have the last line, 0.05 meter cube final cake per meter cube of the filtrate. Okay, that means if somehow I'll manage to find the volume of the final cake, then if I divide the volume of the final cake with this value, then I will get the meter cube of the filtrate, that is the volume of the filtrate. So how I can find the value of the final cake? This is, there is 0.05 meter cube of final cake per meter cube of filtrate. This is the value. Mark it as 1. Volume of the final cake, since the frames are full of the cake, so zero point 0.6 into 0.6 into 0.025 into 20 frames we have. So 0.18 meter cube of final cake. This is the value. Now dividing 2 by 1, we will get 3.6 meter cube of the filtrate. Now 10% of this value is the volume of the wash water used. Okay, so I put it the 10%. Now for plate and frame filter press, the rate of washing is given by 1 by 4 of the rate of the filtration. But for batch filter, rate of washing is equal to the rate of filtration. Okay, so remember this concept. For plate and frame filter press, rate of washing is given by 1 by 4 rate of filtration. Now, what is rate of filtration? So time of washing will be 0.36 meter cube filtrate divided by 1 by 4 of dV by dt. This is the rate of filtration. So what is the rate of filtration? The basic equation. It will come from the basic equation. This is the basic equation of the filtration. Just rearrange and you will get this one. And filter medium, where K is this and beta is this. And filter medium resistance is negligible. That means Rm will be 0. Okay, Rm will be 0. So beta will be 0. Okay, so we'll get this value finally. So we have to find this value. This is our rate of the filtration, and 1 by 4 of this value will be rate of washing. So let's see. So integrating this equation, we will get this plus c will be the constant of the integration. At t equal to 0, v equal to 0, then automatically c will become 0. So now k will be this. We will not leave the unit. Okay. So putting the value of k here, okay, you will get rate. So dy by dt will be, I just put the value of k here and putting all the values, all the units, and we'll get this. Okay, this is the rate of filtration. 1 by 4th of this value. 1 by 4th of this value will be rate of washing. So the time for washing will be 1.6 hour, 96 minutes. Okay. So if you have any confusion in this question, you can just comment it below. I'll try to reply as soon as possible. Okay. And one important information I want to tell you guys is that one of my friends suggested me to separate the channel for chemical engineering and just for my personal blogs. So uh, I just want to tell you that I have made a new channel just for the chemical engineering. I will upload all the solution from today onwards there only, and just go and subscribe that channel as well. I'll The channel name will be visible to your screen. Okay, so just support me, guys, and sub those who have subscribed my first channel, subscribe that channel as well. Okay, and so going to the next question. This is from heat transfer and very specifically from radiation. Consider three infinite parallel plates. Plate 1 is maintained at 1, 2 to 7 degrees Celsius and plate 3 is maintained at minus 173 degrees Celsius. Emissivities are equal to that of the black bodies. That means all the emissivity of the plate is equal to 1. Plate 2 is placed between the plate 1 and 3 and receives no heat from the external source. Okay. What is the temperature of the plate? Okay. So there is only the heat transfer through radiation and nothing external source is there. So very first, this is the diagram. So plate 2 is placed between the 1 and 3 and 1 is maintained at 1 to 27 degrees Celsius minus 173 degrees Celsius. In radiation, always remember you have to convert the degree Celsius into Kelvin. Okay. So we have to find the temperature of plate 2. For plate 1 and 2, heat flow through the plate by radiation will be equal to this formula. We know that. Okay. For heat transfer, there is a wide variety of solved problems in R.K. Rajput. So I will refer that book for specifically for heat transfer. Okay. And okay. For plate 2 and 3, heat flow through the plate by radiation will be equal to this formula. The formula is same. This is between plate 1 and 2. This is between plate 2 and 3. Okay. We know that flux is always remain same between the plates. Okay. Whether it is a cylinder, composite cylinder, wall, composite wall, okay, sphere, composite sphere, flux is always remains same. So equating 1 and 2. Okay. So I just equate 1 and 2. Since E1, E2 and E3 all are equal to 1. Okay. So we will get finally this. Okay. And solving this equation, we will get this. In degree Celsius or whether the question asking in Kelvin, we have to put the value in accordance with the question. So this is the final answer. Okay. So going to the next question. A nickel steel rod 8 centimeter outer diameter originally at a temperature of 300 degrees Celsius. So this is the initial temperature of the rod is suddenly immersed in a liquid at 100 degrees Celsius. This is the atmosphere. Atmosphere is a liquid of 100 degrees Celsius in which the rod is immersed. So TA will be 100 degrees Celsius for which the convective heat transfer coefficient is 100 watt per meter square Kelvin. Determine the time required for rod to reach the temperature of 150 degrees Celsius. Okay, so we have to calculate the time at which temperature is 150 degrees Celsius. Okay, so the other values we have. So very first thing, we will calculate the Biot number. Biot number is this. Since it is a unitless, so we will get a unitless. Just LC is the characteristic length For cylinder it is R by 2. For sphere it is R by 3. Okay. So you will get Biot number 0.025. If Biot number is less than equal to 0.1, so unsteady state heat transfer will occur, and the formula is this. T is the temperature. It is the cursor. Okay, this. T is the temperature at which we have to find the time, that is 150. TA is the atmospheric temperature in which we have put it the object, and Ti is the initial temperature of the object. Rho VCP upon HA into T. Rho is the density of the object. V upon A will be the characteristic length. Okay, so we will put the directly the value 0.02. Okay, we have calculated this 0.0. Okay, so after putting all the values, we will get this, and solving just mathematical things, taking log and all, we will get this. Okay, so if you have any kind of doubt, just comment it below, and I'll try to reply as soon as possible. Okay, and I'm requesting you guys just to subscribe to my new channel, that is only for chemical engineering. We will solve all the other questions, all the questions after 1992, 1993, 1994 till 2024, and I'll upload there only. And so bye guys, take care and study hard. Okay.